So quite a few of you have been asking for extra notes on these kinds of problems, so I'm going to be going over some of that with you all as best I can. This is one of those things kind of hard to teach from a distance. It's easier to be here so I can kind of explain things to you all one-on-one, but I will do my best. So again, the core of all of this is a right triangle, and we've been working with three functions. We have our sine function, which is equal to the opposite length of a triangle, the opposite side of a triangle over the hypotenuse of the triangle. We have cosine, which is adjacent over hypotenuse, and we have tangent, which is opposite over adjacent. This here is the core of all trigonometry. This is what you need to make sure you understand before you try doing anything else. Okay? So like if I said this was my reference angle, and I gave myself these side lengths here, I need to be able to recognize that if this is my reference angle, I need to be able to label my sides. So across from the right angle is always the hypotenuse. Across from the reference angle is always the opposite, and the last one is always the adjacent. It's the one that touches both the right angle and the reference angle. So in this situation here, what I need to be able to do is I need to be able to use these sides and find my ratios. So here I have opposite over hypotenuse. And one thing that's king, for my first through third period classes, that's the other teacher for our class. And for my fourth period class, she's, again, my first through third period co-teacher. She suggested trying something like this, making a list of your three sides over here every time. Because we know that H is 5. We know that O is 3 and A is 4. Because sometimes it's easier if we have a list to be able to look at this versus look at the triangle. And then over here, you just fill it in. So we know sine is O over H, which let me get rid of this real quick. Well, we know that if sine is over H, O is 3 and H is 5, so this is 3/5. And it does have to be in this order. 4 over 5 for cosine, and 3 over 4 for tangent. Now, I feel like a lot of times it may not be this step here that's the problem. It's knowing which function to use. So if I give us another blank triangle, and let's make up some numbers here. So 18 and 12, and let's say we're trying to find this angle up here. Okay, so in this situation, we're solving for an angle. But to be honest, for the first step, it doesn't matter what we're solving for because we're going to set them up the same way. So recognize what your reference angle is, and it's going to be whatever angle is given to you in here. Don't use this though. Label your sides. Well, across from the right angle is the hypotenuse. Across from my reference angle is my opposite side, and across on the opposite angle, but the only one left is the adjacent side. It's labeled. And if you want to, make that little list, keep it organized for you. Hypotenuse, opposite, adjacent. Hypotenuse is 18. My opposite side I don't have anything for, so I can mark that out. Adjacent's 12. So, the way trig works, if we go back to this list of functions, each one of these three functions has a unique pair of sides. No two are the same. So if you look here, we only have the adjacent and the hypotenuse to use. So I need to figure out which of these uses the adjacent and the hypotenuse. And that happens to be the cosine, which means the function that I have to use is cosine. That's how you figure out which function to use, is which sides do you have. If you have all the sides, then you get to pick which ones to use. If you only have two, then you have to figure out which of these you can use. Now, beside cosine is going to go the reference angle, which in this case is an x. And if this is an x, that means we're going to be solving for it. Then to set up the sides, what I need to do is look at the cosine function. Cosine is equal to adjacent over hypotenuse, which means I need my adjacent side first, so 12 over 18. And then I'm set up, good to go. Now, the nice thing about solving for angles is it's really, really easy, okay? Which I'm going to pull Desmos because I will need that in a moment. So whatever function that we use, this time we're using cosine. So I'm going to use cosine, and I'm going to do the inverse of it. And this fraction that I found goes inside of this parentheses here. And the reason I use inverse is because I'm solving for an angle. So now if I go into here, hit the function button, and type inverse cosine. And then I type in my 12 over 18. And there's my angle. Now the nice thing about cosine and sine is if you type it in backwards, like if I did 18 over 12, it won't know how to use that because cosine and sine always have to be less than 1 inside of here. So 12 over 18 is cosine. Inverse cosine of 12 over 18 gives me an angle of about 48.2 degrees. So if you can set this up, that's the hardest part. Because then whatever function you use, do the inverse of that. Then put your fraction inside of that, and you're done. Now, when it comes to the side lengths of a triangle, this might be a little bit more challenging. Let's get this up, I don't know, like a 43 degree angle here. We'll do 15 and x. The only reason this is more challenging is because you have more steps sometimes. I'm going to go ahead and list this here. So, find the reference angle. If you look inside of the triangle, the only angle that we're given other than this is this angle here. So it's the reference angle. Label your sides. Across from the right angle is my hypotenuse. Across from the reference angle is my opposite side. And the last side down here, that we haven't used yet, is my adjacent side. And then fill in your list. Hypotenuse is the side that has 15 on it. My opposite side has an x. My adjacent side is blank. So I can mark that out. So I only have the opposite and the hypotenuse I can use. So if I go back to my list of functions, only one that has opposite and hypotenuse is sine, which means that I have to use sine. Can't use any of the other. Then besides sine, I put my reference angle, which is 43. Equal sign. Then I set up my ratio. So sine is opposite over hypotenuse. So it has to go in that order. Some people get confused about which order to put their sides when they get to this point, whether they should put the 15 on top or the x. But if you look at the function itself, it says that the opposite side is on top and the hypotenuse is on the bottom. So that right there tells you which of these sides needs to go on top. It should be the x because it's the opposite side. So in this situation here where we have x on top of a fraction, I'm trying to solve for x. So we want to get rid of the 15 on the bottom. The opposite of dividing by 15 is multiplying by 15. So I multiply both sides by 15, which gets rid of that. And I'm left with 15 times the sine of 43 equals x. So as long as you can label your sides and set up this equation in blue, it's pretty easy. Just multiply both sides with what's in the bottom of the fraction. And then it comes time for Desmos. And here, which if you're using a TI-84, make sure it's set to degrees. So 15 sine of 43 gives me my answer. And the reason you want to set to degrees is because my answer right here is 10.2. But if I change the radians, then it's negative 12.47. So if it's in the wrong setting, it won't be good. Desmos defaults to degrees, so you don't have to worry about that, but the TI-84s usually default to radians. So yeah. So anyways, this is 10.2. Okay, so let's say for a second that I have another triangle. And I've got say I have a 43 degree angle here. Let's say I've got X over here, and I've got 13 down here. I don't know why I used the 43 degree angle again. I just did. Make a little list, and then find your reference angle, which is here. Now label your sides. Start with the right angle, go across, you find the hypotenuse. Go to the reference angle, go across, that's the opposite. And then the last one is the adjacent. Now fill in your side lengths into here. H, the hypotenuse is X. The opposite side we don't have anything for, so I can get rid of that. And the adjacent is 13. Okay, so the only two sides I have are adjacent and hypotenuse, which is cosine. So I know that I have to use cosine. Then again, I put my reference angle beside it. And I set up my ratio, my fraction. So cosine is adjacent over hypotenuse. What that means is my adjacent goes on top, my hypotenuse goes on bottom. And I'm set up and good to go. Now, when we get to this point here, which actually I'm going to adjust that a little bit because that bugs me. That's it better. I want it to solve for x, but x is on the bottom of the fraction. So I can't multiply or divide both sides by 13 because this is going to mess it up. So normally what we would do here is we would multiply both sides by x, then divide by the cosine of 43. But to skip all those things, what I want to do here is say the cosine of 43 and the x are just going to trade locations. And what I mean about that is where this cosine of 43 is, now there's an x. And over here, the 13 stays where it is, and then I have cosine of 43. Now, make sure it's the cosine of 43. Don't just move the 43 over. Some people like to do that. These two things cannot be separated from each other ever. Cosine and the 43 have to stay together. And if this is confusing you, well, just think this. If x is on the bottom of my fraction, then I'm going to take my side length and divide it by the function of my angle. So 13 divided by cosine of 43. Which, if I go to Desmos, all I have to do is type in 13 divided by cosine 43, and my angle is 17.8 degrees. Sorry, my side is 17.8 long. Did I say this one was degrees? I did not. Good. On the side length. 17.8 is the side of my length of my hypotenuse. Okay. So if you have any questions, let me know. And if you are still struggling, hop in our class meets today. Okay? So good luck. Let me know if you have any questions.